Soil stabilization by using scrap tire rubber. Abstract: the amount of tire wastes, an unwanted urban industry surplus, has been increasing every year throughout the world. One of the chances to dispose of this waste material is to use these refuses as a stabilizer in soils, in order to increase the strength properties and the bearing capacity of the soil stabilizer mixture. In this thesis, in order to study the influence of crumb rubber waste on relative density and shear strength, series of experiments have been performed on dune sand samples with different dune sand-crumb rubber ratios. Various dune sand-crumb rubber mixtures having 0%, 5%, 10%, 15%, 20%, 25%, and 30% waste crumb rubber particles by weight were chosen. To find the effect of waste crumb rubber on shear strength, direct shear test device has been used. It was found that addition of up to 20% of crumb rubber to dune sand noticeably increased the shear strength parameters, cohesion and the internal friction angle. The dune sand crumb rubber mixture created more plastic material and produced an apparent cohesion in the crumb rubber treated dune sand. Since dune sand crumb rubber mixtures are lightweight materials and they apply less lateral earth pressures on retaining structures, application of crumb rubber into the dune sand is still promising. Keywords: soil stabilization, scrap tire rubber, crumb rubber. Introduction. Soil is the smallest natural element which exists on the Earth's crust, and it is one of the oldest natural mortars that has been used in the construction industries during time. Das. 2009. The world's architecture and the ruins of its work are indebted to this element and its attributes. Despite all the new materials we have nowadays, large amount of soil is still being used directly or indirectly in the construction industries. As of the creation view, soil is the final production of weathering, result of physical destruction and chemical degradation of stones along with aggregation of leftovers of the organisms in decay by nature, biodegrades. Das. 2009. All along the history, mankind has been trying to find a better use of soil in different matters. We can find the origin of this idea in natural models and examples. Lots of species, especially birds, they mix soil and tiny branches to build their nests, or the hillsides will be stabilized by the plant growth and their roots. The idea of mixing straw and clay to build thatch mortar, or recently the use of shredded tires and polymer fibers to reinforce the materials and soil structures are the samples of this idea. Das. 2009. Soil reinforcement is one of the geotechnical branches which has been reinforcing and improving the soil engineering specifications and mechanical properties like strength, plasticity, bearing capacity, and elasticity modules by the use of new technologies and two suitable materials. Craig. 2004. Soil reinforcement is a reliable and effective method to improve the soil strength and stabilization, which has always been the human interest. Around 3,000 years ago, Babylonian used reinforced soil with thatch to build their temples. Mwasha. 2009. At the present times, the elements which are used in soil reinforcement are made of metal or polymeric materials, or even herbal like jute and coir fiber geotextiles. Galanmaran et al. 2012. Friction phenomena between the soil and its reinforcement materials play an important role in mechanism of action and behavior in soil. One of the methods of soil reinforcement is integration of soil with fibers like natural, glass, polymer or other synthetic materials. Mixture of these elements with soil creates a complex environment in which the involvement of the elastic parts, reinforcement elements, and soil particles improves the soil strength and plasticity in many ways, like increase in peak strength, reduction in post-peak loss of strength and axial strain at failure. Harry et al. 2000. There have been many elements like metal fibers or fiberglass or polymeric fibers and etc., which have been applied to soils as soil reinforcement. Harry et al. 2000, and Jewell and Greenwood, 1988, studied the mechanical effects of geotextile reinforcement. Prabhakar and Shrither, 2000, investigated addition of sisal fiber. Jung et al. 2007, studied the glass fiber reinforcement. We can categorize the methods of soil reinforcements into three categories of mechanical, physical, and chemical processes. Literature review. Being the most available material, soil has always been used in construction of different structure like buildings, roads, and dams. Due to weak mechanical properties, the structures made of soil are much bulkier, heavier and dimensionally larger. Because of these weaknesses, there are many researches aimed at enhancing the mechanical properties of soil and increasing its strength via adding different materials. Reinforced earth is one type of enhanced soil that its tensile strength is increased. Although the addition of tensile-resistant fibers to soil have been practiced by ancient civilizations, but the new technologies and advances in this field made the use of soil economically and technically much more justified and feasible. There are many methods and technologies in use to increase the tensile strength of the soil through mixing various additive or fibers to soil. Since the introduction of these methods, comprehensive theoretical and practical researches have been underway and some codes and standards developed for these methods. The reinforcement of the soil is not new concept, and its first applications goes back to 4,000 to 5,000 years BS when hay or straw were used to reinforce the clay or bricks. There are other evidences indicating use of reinforced soil in China wall, and also ancient African and South Asian people used bamboo sheets, straw, and date leaf in their buildings. One of the materials used for enhancing the properties of soil is tire-derived products like tire shreds, crumbs or powder. For this study, a comprehensive literature review has been carried out that is summarized in this chapter. It covers the material properties of recycled tire, related tests, and geotechnical applications of this material. Methodology. 3 phases were conducted to perform overall testing program. In first phase we study the geotechnical characteristics of the dune sand and physical properties of shredded tires, which were already being discussed. In the second phase, to calculate the different percentage of waste tires, we calculates the maximum dry unit weight and minimum dry unit weight for the mix by the use of relative density table apparatus. To determine the relative density of cohesionless, the relative density test was performed by the use of free draining soils on a vibrating table. The relative density of a soil is the ratio, expressed as a percentage, of the difference between the maximum void ratio and the field void ratio of a cohesionless, free draining soil, to the difference between its maximum and minimum void ratios. The purpose of observing the behavior of dune sand-crumb rubber and their mixtures, standard direct shear test device, 60 mm x 60 mm, was utilized. The thickness of the samples was 50 mm. All tests were done based on the method explained in ASTM D3080-72, 1989. In all tests, 3 normal stresses of 50, 100, and 200 kPa were applied. Samples included pure dune sand, crumb rubber, and their mixture based on different percentages of weight of 0%, 5%, 10%, 15%, 20%, 25% and 30% crumb rubber mixed with dune sand. Numerical calculations of each sample were done based on the maximum and minimum of dry density, and the relative density of 70%, as a dense mixture, was considered to determine the weight of the sample to be compacted in the shear box device. When the samples got ready, placed in the shear box, and by reached the relative density, by compacting, the normal stresses were applied and samples were sheared. All the tests were done based on controlled displacement. Shear rate in standard direct shear test is usually controlled by an electric motor and a multi-speed drive unit, typically providing 24 speeds ranging from 5 mm/min to about 0.0003 mm/min. Head, 1982. In all experiments that were done in this study, shear rate was considered 1 mm/min, which was close to the rates considered by other researchers. The waste crumb rubber RA used as this study was taken from the waste tires industries in different form, i.e. powder, chips and shredded form. The size of crumb rubber used in the study are ranged from 0.82 mm. Fig illustrate the grain size distribution curve of crumb rubber. The engineering properties of crumb rubber. Percent crumb rubber. Maximum dry density. Minimum dry density. Dry density, D, Kn/m.